Welcome to section 9.8. This is the 79th session of the CISSP exam prep series. In this session, we'll look at high-performance computing systems. We'll answer 4 questions. What is high-performance computing? And where do you actually meet it? What 3 pieces have to work in balance? What is a benign denial of service? And why does it matter? And how do you keep these platforms healthy? Why does this matter beyond the exam? Because these systems sit under things you already depend on. Picture a weather agency modeling a hurricane, a bank scoring fraud in milliseconds, and a studio rendering a film overnight. Each one leans on raw computing muscle to deliver on time. When you understand how these platforms are built, you can spot where they break and defend them before the workload stalls. So what exactly is high-performance computing? It is a platform built to crunch huge calculations or process massive data at extreme speed. Supercomputers and massively parallel systems are the classic examples. You reach for them when a task needs results in real time or close to it. Scientific research, medical analysis, voice assistance, and machine learning all ride on this horsepower. Think of it as a fleet of engines working the same job at once instead of one engine straining alone. What 3 pieces have to work in balance? Every high-performance setup rests on compute power, network capacity, and storage. The catch is that they must match each other. If storage is too slow, it cannot feed data to the processors fast enough. If the network is too thin, users hit latency or the whole thing chokes. Picture a busy kitchen. Fast cooks are useless if the pantry is slow or the servers cannot carry the plates out. What is a benign denial of service? And why does it matter? It is an outage that no attacker caused. The service simply runs out of headroom. Maybe traffic spiked because something got popular, or a drive failed, or a config went bad, or a network link dropped. Nobody attacked you. The system just met a load it was never sized for. It teaches an important lesson. Availability can collapse from honest mistakes and plain bad luck, not only from malice. How do you keep these platforms healthy? You size every layer to the real workload and keep the 3 pieces in proportion. You add capacity before demand outgrows it, and you watch for the early signs of strain. Since datasets and connected devices keep multiplying, demand for this horsepower will only climb. Plan for that growth, or a benign outage will plan it for you. So let's bring it together. High-performance computing crunches enormous workloads at extreme speed for science, industry, and everyday services. It stands on 3 matched pillars: compute, network, and storage, and each must keep pace with the others. A benign denial of service reminds you that availability can fail with no attacker in sight. Size for the load, watch for strain, and plan for relentless growth. Get that right, and the horsepower stays available when the work arrives. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.